Good morning, students. You are welcome to today's Google Classroom. And still under dynamics, we'll be talking on forces and motion. And under forces and motion today, we pay attention to projectile motion. So at the end of today's class, you will learn how to explain and define the concept of projectile motion, and trajectory. Also, you will learn different components of projectile motion. You will also learn how to derive various formulas used in projectile motion. So, let's go. Projectile is any object thrown into space upon which the only acting force is the gravity. I want you to pay attention that the only acting force is the gravity. That is, gravity is the only primary force on a projectile. For example, an object dropped from rest is a projectile. Also, when you have an object that is thrown vertically upward, is also a projectile. Also, object which is thrown vertically upward at a particular angle is also a projectile. All these are possible, provided that the influence of air resistance is negligible. Provided that the influence of air resistance is negligible. You have to pay attention to that. And then let's see what is projectile motion. Projectile motion can be defined as the motion of an object projected into the air at an angle. In a projectile motion, the only acceleration acting in the vertical direction, because we have horizontal direction and we have vertical direction, but the only vertical motion acting in the vertical direction is acceleration due to gravity. The projectile motion consists of two parts. I've mentioned that before. The horizontal motion, where there is no acceleration. I want you to pay attention to that. And also, we have the vertical motion of constant acceleration due to gravity. The projectile motion is always in the form of a parabola, which is represented by this particular equation. So let's talk about trajectory. Trajectory is the path followed by a projectile. So I can try to show that from diagram. If a body is projected either through a cannonball projectile, this particular path is what we call trajectory. And we have trajectory equation, which is represented as y equal to x tan theta minus, we have g x squared all over 2 u squared sec squared theta. That is equation of the trajectory. We can now say, let A, if your A represents g x squared over 2u squared sine, maybe, sorry, let's remove this one. Let's try to take, that is, if A represents g, I don't want to have the x there, so that we can use it. So we have g over 2u squared, then sec squared theta. And if b represents tan theta, if that is the case, we can write this equation as y equal to x tan theta minus, all this one is here, that is ax what? Ax squared. So this is a general equation of a trajectory. Also, we look at the time of flight. That is the time taken for a particle to return to its original level. Again, we talk about the range. The range is the horizontal distance covered when the particle returns to the original level. So let's pay attention to this, that since the horizontal component of a velocity is constant, horizontal component of the velocity is constant, the range will therefore be equal to the product of the horizontal component of the velocity and the time of flight. This is, we denote range by r. So let's see from the diagram. In today's Google class, you will learn how to use this diagram to derive the greatest height reached during the motion represented by h. We also learn how to use this diagram to derive the formula for the time taken to reach the greatest height. We also use it to derive formula for the time of flight and the horizontal distance, that is the distance from here to here, and the velocity v at any at any time t during the motion. This is what we'll be doing in the Google class today. So please get ready and let's start working.